Hello and welcome back. So in our last video we developed a fan which kind of completes the first step of our design process. In this video we're going to be taking the next step and doing the next two pieces of our vacuum cleaner. Now the reservoir and filter design are some of the most critical components to a vacuum because if you think about it, the dust bin in a vacuum is the piece that most users interact with. You have the design and you're using it as functional, but when you actually go to use the dust bin, you are removing it, you are disassembling your system and then reassembling it. So the design there is, it has to be really user friendly, because when you have a reservoir, it's not easy to design something that where it's a good dust collection system. It has a good filter system and it's not shooting dust back out into the environment, but at the same time it maintains its strong suction and that kind of thing. So my advice to you would be spend some time studying dust bins. You go look at a shop vac. Shop vac has a very simple dust bin collection method. If you're going to go with a shop vac or design, it's very simple, and that can be really nice. If you're going to go with more of a household vacuum style, you will get it a little fancy with your dust bin. Now my goal here is to have a little bit more fancy of a dust bin, so I'm going to put that together. Now I also have to keep in mind here, as I build this dust bin, I am likely going to have to go back and edit this piece in the future, because as I put this together, it's going to have to evolve. It's going to have to change as I work on building connections with other pieces. I may have a connection to another piece that I established where I want it to connect in a very certain way, and so I'll have to go back and modify this original piece to make sure that can happen. Now there's benefits and minuses to that. It becomes a very iterative process where you don't have a full design until you've gone in and edited each piece like 3,000 times. And that's okay, as long as you keep all of your parts, all of your current parts, in a folder close to each other so that you can work on all of them together, or as long as somebody designs a part, submits it to the group, make sure that all the parts are working just well, you'll be in a good place. So I will warn you that all of these, basically from here on, are going to be some of the most time-intensive pieces. Here, your housing itself, the body, has to connect to pretty much every other feature. So that it becomes a very complex part very quickly. And I am requiring you to show how you connect everything together. So this is not going to be a simple project. There's going to be a lot of parts put into this. Might be a good idea for you to establish, like, we're going to use this size of screw, and everything we're ever going to use is going to use this size of screw, because then you only have to make one and build the assembly line out of it. So, but we'll get into those later. But do realize that the fan, reservoir, filter, motor, while they are critical to the absolute performance of the item, the actual design process for those is very minimal compared to the rest of the design as a whole. So, but we're going to go ahead and knock these two out so that we can get to the rest of the design. So I'm going to start by making a new part. Now, when I say reservoir, I do mean dust bin. I call it a reservoir because sometimes it's filled with water, sometimes it's just in air. You can also have like a foam reservoir. You can also have like it's kind of a goopy type reservoir that forces air through it, and it's kind of an interesting concept, but it's modeled after the human mucus system and how it collects and traps dust to prevent damage to your body, which is also kind of gross, but whatever. Anatomy is gross, but that's coming from a biomedical engineer. But I'm gonna just design mine to be very, very akin to a regular vacuum cleaner. Now the types of dust bins that I'm most used to are these like shark dust bins, where here you have the input that comes in here, the air cycles around, and as it cycles around, it kind of throws the dust out of this portion and out into the rest of this body. It's nice. I like that because basically what you end up with is, as the dust is down here, you'll have some maybe larger debris that gets caught up here, but most of the actual debris and anything you want to throw away is down here. And the outlet to that vacuum is right here. So in this reservoir, you do have to study where's the input, where's the air coming in, it's coming in, and then it goes out through this central chamber. And it does create a kind of a, because of the offset of this, it creates a kind of a cyclone that propels all of your items down here into the base. Now we could easily go look at a shop vac, a dust bin, and if you look at these, oftentimes what they are let me see if I can just pull up images. Oftentimes what they are is it's just a tube that comes in, and then you have this base here, and then the shop vac head is, it has all of the suction up here, and it just throws this giant filter on the bottom here that shows the filter that sits on the bottom of it, and it just sucks air through this huge filter. This filter kind of looks like this, up to the fan unit up here, which is up here in this piece. And that's what it does. That's how it works. So it's a really rudimentary design, really simple. Now shop vacs are not known for being particularly dust friendly. They can tend to shoot out a lot of dust, and the dust collection system tends to be really gross, but it's intended for more industrial uses. So here, if I want to look at hand vacuum dustbins, here, the hand vacuum dustbin, it all goes into this dustbin, and then the vacuum portion is right up here. This is a little bit smaller than what I want. I want to build something a little bit closer to something like this. But here, all this is it's just this is a Dyson system. It's just a chamber where it forces it to kind of spin around, but then the air comes out the bottom. So I kind of like that cyclonic technology. That's we've shown that if you propel particles in a cyclone, it tends to make the vacuum portion much easier to handle. So that's kind of how I'm going to design mine now. Looking at different models of reservoirs and going and looking up different model numbers, maybe even going to Walmart and looking at some different style of reservoirs. Yeah, all of that's great work. That's all work that would really help you identify good pieces. But what I'm seeing here is that this Dyson vacuum piece kind of pops onto the bottom. I like this because it's very simple. It's easy to work with. It's ergonomic. Somebody's already come up with it. It clicks in right here. So, and then I believe this would have a dust cap that goes on the top of it. No, it has a lever on the bottom that you can activate to release it. Okay, that's nice. So I'm gonna go ahead and design my reservoir a lot like that. So here I'm gonna do a sketch. I'm gonna close this window real quick. Doop. I'm gonna do a sketch. Here I am gonna do a sketch on the top plane again because I am a normie. And here I want a circle, because this is just going to be the foundation of my design. And then I put it on the origin, smart dimension it, dimension the outside of this circle. I want it to be about 4 inches in diameter. I don't want it to be too massively huge. The irony is that my fan itself is bigger than this unit. I'm gonna have some incredible suction powers. You know what? I better make this. This is gonna be a hand vacuum for. Oh. There we go. Hand vacuum. Exit sketch. Now when I go to extrude this, I can do an extruded boss base. There's two ways that I can do this. First of all, if I just want this to be like a mean diameter of 6, but I want that to be a thin shelled plastic piece, what I can do is I can just do a thin feature and then extrude this up, I don't know, maybe 5 inches. And so what this will do is now I have a thin feature, just a tube. That's what makes it, that's what the thin feature does. And I can change the thickness of the walls by going down here and clicking on 0.1 inch. That's one way of doing it. The other way of doing it is I can go in and do a shell, which it'll cut out everything but one surface, so it'll turn it more into a cup shape. Here I am actually going to make this be a thin feature, because what I want to do is I want to kind of put that cap on the bottom so that the dust can be emptied from the bottom. And we'll go with that. So yes, I am totally about to rip off Dyson here. And no, I don't feel bad. So I'll go ahead and hit yes. And there I go. I have my reservoir. Now I'm going to have to make this an assembly piece, but I'm going to worry about that a little bit later. The next piece of this is I have to establish my inputs and outputs. So here I would like my input to come in from the side like what we were seeing with those other vacuums. And I do want it to be offset a little bit. So I am going to do a second sketch. In here, I'm going to do my second sketch on the front plane. So here, front plane is right there. I'm going to go ahead and orient my views so that it's looking at the front plane. And then what I'm going to do is I'm going to draw a circle like this. This is going to be my input tube circle. And yeah, I mean, it'll come in and be tubular. It's terrible. Now, according to this design, I'm going to try to design it so that it is integral to the piece. I don't actually want this piece to be removed. So my inlet's going to be in one place and my outlet's going to be in another place. And as a result, I hopefully am not going to be dealing with a very challenging component, but we'll see how that works out. I want this to be offset again because it's going to cause this thing to circulate inside of this tube. So the first thing I'm going to do is I'm going to identify the circle. I'm going to use tube diameters of about 1 inch. It just makes everything a little bit more compact. I guess I could use 2 inches. 2 inches about this big. Inch and a half maybe. We'll do 1.5 inches. So all of my tubes I'm going to try to make 1.5 inches. Okay, so I've established that. Now I want it to be offset from this center point by 2 inches. And I want it to be offset vertically by 3.5 inches. It's just because that's really close to where I currently have it positioned. That's nice. So you'll notice it's fully defined. Go ahead and exit sketch. Now I drew this on the front plane. If you go in and look at it, it's right there. I'm going to be cutting a hole in this side of the reservoir so that I can route a tube there. So we'll go back into features and then we'll do extruded cut. And then what I'm going to do with this extruded cut is I'm going to make it go through all. Now if I hit through all both, it'll go through both sides. I don't want to do that. Here it's trying to cut through that side. I don't really want it to cut through that side. I want a flip side. Nope, nope. I want to have it cut this way. So I'll hit yes, and it'll cut a hole right there just like that. Okay, well that's nice. It's a pretty looking hole. Okay, but I want a tube that goes to it. So I am actually gonna have to step back and do an interesting fix. So bear with me here. I'm gonna create a plane. We'll hope that my computer can catch up to what I'm trying to do. And I'm going to make this be an offset from the front plane. Okay, but I want it to be offset by, let's see, this is a 3 inches radius, so this will be 3 inches from the front plane to here. I want it to go out another 1.5 inches, so 4.5 inches from there. Okay. And that's I'm going to draw my tube on here. Okay, so follow with me, follow with me. I'm going to sketch, and I want to sketch on this plane 1. Since I had plane 1 selected, it automatically decided that I wanted to draw on it. Nice work. I'm going to orient my view so I'm looking at where I'm at, and then what I will do is I will draw a circle, and here I want this to be again, I said I wanted my tubing to all be 1.5 inch diameter. I actually want that to be 1.5 inch outer diameter, so I'll hit 1.5 inch. And then I will establish this vertical distance as 3.5 inches, as I've already done. And this one, you know, I probably could have just copied this drawing instead of recreating it twice, but it's whatever. I don't care that much. Let's see, I think I had this at like, what, 1.5? No, is that 2? Yep, there it goes. Okay, so I'm gonna hit OK. And then I'm gonna exit sketch. Now that was fully defined, and I have this piece here, this just circle right here. What I can do is I can go in and I can do an extruded boss base. I'm going to select my circle. And then what I want to do is I want to extrude it to this reservoir. So instead of doing a blind, it's going to go up to surface. And then I'm going to switch the directions. And then I have to pick the surface that I want it to go up to, which is this one. You'll notice it just kind of goes all the way through. I'm going to make this thin feature, and that will fix it because they are the same size. And now all I have to do is hit OK. And it did say to merge features, so this is now considered all part of one part. So there we go. We have an inlet valve. Okay, so I'm going to have air come in here. It's going to kind of spiral around, and then I'm going to have an output port where basically the air is going to spin around, and then it's going to go through a tube in the center. So I'm going to go ahead and create my tube in the center as well as the top piece here, because those are kind of integral. But I am going to make those two. I'm going to make it part of this piece. Why not? So here we're going to sketch. I'm going to do a sketch, and I'm going to do it on the top plane, which is where I have that. So go back and click on the top plane again, so I can draw right here on this base. I'm going to orient my axes. Okay, and now I'm going to create a tube from this center point that just goes up. Okay. So I'll do a smart dimension. Let's see. I'm having all of my tubing be 1.5 inches. Just because I like consistency. And then I'll hit exit sketch. Okay, so there's my circle. I'm going to extrude it up to the top here. Dang it. Nope, I'm actually going to go back and delete that. I don't want it to be drawn right there. I'm going to draw a top piece, and then I'm going to extrude downward from that. And that's just so that I don't have to try to make some very funny geometry. Typically what they have for the tubes that drop down is they're perforated. They've got holes in them. I don't want to do that because I am not trying to design a vacuum well. I'm just trying to design a vacuum. So we'll try this again. I'm going to sketch. And when I sketch, I want to be drawing on this top surface right here. So I will quickly go and reorient my view. And then what I'm going to do is I'm going to draw 2 circles. One from here to the outside there, and one from here just to there. Okay. Now I'm going to dimension this one. This one I want to be 1.5 inches, as I've said. So the hole for it is going to be 1.5 inches. Now that's fully defined. Now this one out here is not. And that's because if I click on it and drag it, it's not really defined. So I need to add a relation. So I've got this arc selected. I'm going to select this one. And I'm going to make them be, I think, concentric. No, that doesn't do it. Never mind. I want them to be what co-radial is. Yeah, co-radial. Or tangent. Both of those actually work. Although in this instance, co-radial is just better because it means that they have the same radius. Okay? And now, when I click off of this, those are both fully defined. I'll hit exit sketch. And then what I'll do is, because I want this to be a thin plastic feature, I'm just going to extrude it up 0.1 inches. I cut it on shell. Probably would have been easier. But look, it's already at 0.1 inches. I'll make sure it's going in the right direction. It is. I want it to merge feature because I want this all to be one part, which it is. And there we go. Now my reservoir has an empty bottom and a hole in the top. Okay, now I'm going to create a tube because I want the outlet to be down here closer to the base of this item. And it's just going to come out like that. Again, not really designing this well. No, you know what? I'm just going to leave that as is. I'm going to finish this piece by adding kind of a hinge right here. Basically just a hinge pin so that this can lock. And I am going to yeah, put a kind of a locking clasp right here, piece, so that it can clip on. Actually, no, that's way too designed. I'm just going to put a hinge, and then I'm going to create a plate for the bottom. And then I'll build this into a reservoir assembly so that we can move it as one piece from there. But I do have to add those 2 circles in the back. So what I'm going to actually do here is I'm going to draw a sketch, and I want to do it on the right plane. This is one of the reasons why I wanted to have my origin right in the center, was so that I can draw on all of these planes and have some control over where these planes are. It's always good drawing practice to keep your origin in some kind of a convenient location. So here I'm drawing on this plane. I want my hinge to be about right here. And basically all I'm going to do to make a hinge is it's just going to be a circular piece like this that will have a hole in it, so that I can run a pin through there to connect a piece on the bottom. So create 2 circles, hit escape. Now what I'm going to do here is I'm going to select this point, and then I'm going to select this origin here. Okay, I can hit control and hit both of them. Under existing relations, I want them to be horizontal. Okay, so it'll just means it'll hinge about this bottom piece here. So okay, now I'm gonna add another relation. Actually, I want this piece here to be tangent to this outer piece, so it's like a little circle piece goes on the outside. So I will add relation, pick this arc, pick this edge, make them tangent. Now, realistically speaking, this is only going to connect at one place, and it's not really going to be a very good connection. Tangent probably is not the best way to connect that. I am going to go ahead and just delete this. I'll set a smart dimension from here to the center point. Smart dimension. Right now it looks like it's at 3.5 inches. I only want this to be about 3.25 inches. Okay. And then I want this diameter of this circle to be, I don't know, quarter of an inch. That might be too small. Yeah. I'm gonna change that. I'm gonna pop this up to 1/2 inch. It will intersect the base here, which again is fine. And then for this one, I want this to be 1/4 inch, because that's going to be my pin diameter that I use to connect this piece on. So I'm going to hit OK. It's fully defined. I exit sketch. And then I'm going to go back in and boss base extrude. because I just want this piece. You'll notice it already kind of intersects. It does intersect with this piece there, which is fine. And then I want to go mid-plane extrusion. Basically, I want it to extrude out both sides. And I want this to be about 1/2 inch long. Okay, so it will intersect with this. It doesn't appear that it stops intersecting with it, which is kind of what I want. It's got to have some place to connect to. So 1/2 inch. There we go. Oh, that looks pretty. I like that. Alright, so I've got my hinge joint, I got my input, I got my outlet. I am going to have to put a filter up here, which I will do right after I finish building the rest of my base. I am going extra on designing my base. You probably don't need to do anything like this, but oh well, it's time for me to show you good practice. So I'm going to go ahead and save this piece. Now, as I've told you, you should save all of your pieces in one place. Here, this is my vacuum cleaner. Start date of when I started drawing it, which was 4/1. I'm going to call this Reservoir Body. And hit enter. It'll save it. And then I'm going to create 2 more drawings. One of them is going to be a really simple pin, which is just going to be, it's a plastic pin which will go into hold the reservoir flap on. I'm not going to design the clasp for that thing. This thing is just going to be a flat piece, because I can. So here, top plane, draw a circle, start dimension. This is going to be 6 inches in diameter. Then I exit sketch and extrude this 0.1 inch. And hit yes. So here now I have my flap. Okay. Now I am going to create a method of joining, because you see I have to be able to fit in. Let's see if this pulls up. I have to be able to basically slide on and then surround that, and then pin has to go through all of that. So I've got a 1/2 inch gap right in the center, where I won't have well, that's where that pin comes down, so that it'll connect into that joint. So you know what? I'm going to do something fun. I'm going to do a revolved boss base here. Here I'm going to sketch on this top surface, zoom in normal to it, and then I'm going to draw a rectangle. Now I'm going to draw it a little bit over here and then move it back closer. What I made was I made the this round piece. It's 1/2 inch diameter, 1/4 inch pin diameter. So really that means that I've got 1/4 inch of material between the two sides. So my wall thickness there is 1/8 of an inch. So 1/2 of 1/4 inch. So I've got 1/8 of an inch for my wall thickness, and then for my dimensions, I'm just going to make it be a 1/2 inch on both sides too. So the dimension of this square, I need it to be 0.5. By 0.125. Okay. Now this piece here, from the origin to this top piece is 1/4 of an inch. Well, you'll notice that the dimensions here all get kind of gross. That's fine. In a sketch, it doesn't matter. And the distance from this inner line right here to the origin distance there, we had it be what, 3.25 inches? No, it was 3.25 to the center, so this is 3.125. Okay. Now, as you'll notice, this piece is not actually connected to our drawing. So I'm going to make this dimension, instead of being 0.125, I'm going to make this be a little bit bigger. I'm going to make this be 0.2. And that'll be just so that it connects all the way. Okay, and now you'll notice it's fully defined. I'll hit exit sketch. I am going to very quickly create an axis that I want to revolve this around. To do that, I'm going to have a, let's see. Yeah, I'm going to have to create 2 planes first, so. Alright, we'll play that game. So here, I want it to be coincident, it's now fully defined. So there's plane 1. I'm going to create another plane here. And it's going to be it's not going to be the front plane, it's the right plane. Can I draw on the right plane? I totally drew on the right plane. Oh well, this component's going to have to be rotated. Whatever. That's something we can deal with in the assembly. But I'm going to make this coincident to, oh no. Coincident to the right plane. Oh no, I didn't want that to be coincident. I wanted it to be parallel. I'll just go in here and click plane 2 and edit feature. We'll set it as a distance, and we'll have this be 3.25 because that's the distance to where I want my axis to be. Okay, this will allow me to establish an axis. So here I can create an axis at the intersection of those 2 planes. So I click 2 planes, and then plane 1, and then plane 2. Or face 1, I guess. Works just as well when I don't need a plane 1. And there we go. I'm actually going to delete plane 1 now that I don't need it anymore. There's no dependency. I'll click on this, and I am going to hide it because I will never need it again. I only needed it to establish an axis. Now I have my sketch. I'm going to do a revolved boss base. It's going to ask me what selection I want. I go in here and I click on our little rectangle. For my axis of revolution, I don't want it to be itself, although you can do that. Instead, I want it to be this axis. So it'll rotate about like that. And I'll hit OK. Alright, I have one side of this piece. I need to create the other side. So I'm going to do a quick mirror now that I have Evolve 1. So it's asking me which plane to mirror across. Here I am going to mirror across what is my front plane so that it's on equal sides of both pieces. And then merge result. So this is my bottom cap that I'm going to put on my reservoir. So I'll go ahead and save it as reservoir cap or reservoir flap. Always important to note what subassembly it is when you name it. Otherwise you have to put it in a specific folder just for like reservoir components. Because it's really easy to forget what each piece goes to as you continue to build along. So last piece I'm going to make is going to be the reservoir pin. Again, I'm going to name all of the components that go into the reservoir assembly with the title of reservoir in the name somehow. You can get really detailed in your naming schemes for some of these pieces. Some people will even go so far as to provide material decisions, overall part dimensions. Just a lot of different things go into it. So now this pin that we're creating is 1/4 of an inch diameter and is 1.5 inches long. So that actually should be pretty easy to make. I'm going to draw this in the right plane because I screwed up last time, and this one's actually going to be really simple. Draw this, smart dimension, make this be 1/4 of an inch diameter. And then exit sketch. I am going to do a mid-plane extrusion. That's just because personal preference there. And it's going to be 1.5 inches long. There we go. And then I'll save this as the reservoir flap pin. And hit enter. Now, to finish my design for my reservoir, I need one really nice piece, and that is I need to put it all together. So I'm going to go into an assembly. So new assembly. I'll wait for SolidWorks to stop being dead. Hopefully that happens at some point. Well, you never know. I just realized I haven't drank a Mountain Dew today. Mountain Dew, breakfast of champions. Okay, so now making an assembly is different from making just parts. Here, it's going to ask me, where's my base part? The first part you put in is going to be assumed to be the base. So here it's going to be the base, the component that everything else basically gets mounted to. So here, the reservoir body is what I decided was going to be my regular body piece. Go ahead and put it down. It'll center it. You'll notice over here, it has an F. What that basically means is I can't grab it and move it. I get the error message that the component is fixed. It cannot be moved. So that's kind of what I want. Now I'm going to go ahead and insert components. Because I already have these components opened, it's going to pop them up here. Otherwise, I would need to go down into my Browse tab. I'm going to first put in the reservoir flap. As I told you, this is 90-degree rotated. Bruh. So my nephew likes to put it. So we're gonna put these components together with some mates. First thing I'm gonna do is I'm gonna mate the top piece of this to the bottom of the reservoir, just to make it stay put. So I'll click on this face, zoom in on this edge, which is a face. So you'll notice I have two faces. I want them to be coincident, which basically just means they touch each other in appropriate ways. Okay. Now, the next thing I want to do is I want to align the axis of this to the axis of this pin here. In order to do that, I need to be able to see those axes. So I'm going to go into View, Hide Show, Temporary Axes. And what that's going to do is it's going to pop open these little puppies. So here I can click on that axis and zoom in, click on this axis, and it will align them. Okay. Now lastly, there was an axis that was formed here because I extruded a circle. And then I have this axis up here because I extruded a circle. I'm going to make those be coincident. And what that'll do is it will align all of these. So I will hit yes. That right there is what my hinge joint looks like. It's pretty. It does kind of cut into this piece here, but we're going to ignore that because I'm not really spending that much time here. I'm going to go ahead and get out of the mate menu. I got my flap on. The flap looks good. It's a little bit smaller than the rest of my tank, but it's only about 0.05 inches. Last thing I got to do is I got to put in the pin. So I drew this on the right plane. It's coming in as, it looks like a square. Nice. We'll do two mates. First mate is, I'm going to make this face to the outside face of this thing, and then I'm going to make those be coincident. So all of that does is it just says that I'm going to push that pin all the way in, and here I'm going to mate this axis to this axis here. Whoa. Lost my pen. We'll try that again. This axis here to this axis here. Oh, mate. I feel so Australian when I do this. Come on, mate. Come on, mate. Of course, I could also be an Australian biologist. There we go. And it moves them, set them to be coincident. Hit yes. Okay. And so now you'll notice that I've got a pin that runs all the way. Oh, pin that runs all the way through. If I go into my mates and I delete that one mate that I put on. I think it was the very first one where I mated the faces. Yeah, if I delete this mate, then I should actually be able to grab this. Ah. Oh, right, because yeah, that's right. I won't be able to grab it and move it because this component here, making them concentric, basically prevents it from opening. So, but otherwise you could open that and you could show it. If I deleted that mate, which was the third mate, second mate, no, it was the third mate here. If I deleted that, then I would be able to open this flap, but it would also cause my flap to fly in and out. So, it's fun things. All right, now I have my reservoir saved. I'm going to go ahead and save this assembly. Rebuild and save. It'll rebuild all of the components to make sure that all the components are up to their latest definitions. And then here, I'm just going to put this as the reservoir assembly. It's in the same place as my other reservoir components so that I don't lose them. The assembly piece doesn't actually save the physical parts. I mean, you can see them here, but it's because it's relying on the definitions that are created in a different part file. If I were to close all of these and move the assembly file to a different location, when it opened up, it would be all screwed up. So I'll show you that quickly, just again to reiterate the fact that you don't want to move your components around. Oop, that's the wrong one. That's a project I did last year. I should delete that. Going into vacuum. Here's my first iteration of my vacuum. What I'm going to do is I'm going to take this, I'm going to copy it, and by the way, I'm showing you right now what you should not do. And then let's see, I'm going to go into, sure, why not jump into just a random other folder. Here we go. This looks like fun. I'll paste it here because maybe I also want to use this file in this location. Now when I go to open up this assembly file, it is going to cause me some issues because it's going to have it's currently trying to look for those other components that it's connected to. And if I do this right, if I'm doing this wrong, intentionally wrong, what you're going to end up with is just a giant error the moment I open this file, because you're not supposed to move the assembly without keeping the other components with it. SolidWorks is nothing without all of the part files. The assembly file, all it does is it just basically establishes mates. That's about it. It keeps the save file size of the assembly file down by not having to keep any of the model data from the parts. And that's one of the benefits of doing things this way, is that you only really have to create one part, and then it just creates mates, and you can use that parts as many times as you want without really dramatically increasing the save size of your build. Now, the actual the computational power that's required when you have multiple parts does increase because SolidWorks is a very visual program. It runs on a very powerful visualization type background. So a lot of people will actually build computers just to run SolidWorks. But still, the file sizes themselves are kept to a minimum because it really only identifies the mates, how many parts there are, the orientations of those parts, and then the mates. And what you'll see here is it's trying to go and find those files. I do have those files on my computer, so it might be able to find them and rebuild this document, but it also might not, because it's trying to figure out where those files are. And it's going to struggle a little bit with doing this. So this, again, this just goes to show you, don't move the assembly file without moving the parts. It does actually create problems. I know it ended up finding the parts, which is kind of surprising. But anytime you move from one folder to another folder, you end up really struggling with, you may lose parts. So keep everything together in one folder. If you need to move something or make any modifications, or if you want to create a new iteration, you end up copying the entire folder over. It's going to save you a lot of headaches that way. So that's